Good morning to everyone. Okay. Is the slide is visible or dim?
Visible, sir.
Visible.
Visible. Okay. Okay. Thank you. So today I'm going to start application of differential equation in circuit theory. So today I expect an answer from your side because uh, I think you know basic things in LCR circuits. Especially, I am expecting the answer from circuit theory students, ECE, Triple E, and E and I students. Okay. So now, just I am going to. I think in matrix theory itself, the last semester application of matrix theory. I think. Um, uh, I taught to my students basic in electric circuits. Maybe Aditya, Jaya, Christy, Jaya, are you here? Okay. Okay, but anyway, I need to recall those ideas here. Okay, consider a LCR series circuit shown in this diagram. Okay, containing inductor, resistance, and a capacitance. Okay, the current in a circuit after a switch is closed, okay, is denoted by I of t. And the charge on a capacitor at time t is denoted by q of t. So, and then L, R, C are known as inductance, resistance, and capacitance. And using Kirchhoff second law, the impressed voltage E of t on a closed loop must be equal to the sum of the voltage drop across the loop. Okay, in the voltage drop in the loop. Okay. So in figure 1.34b, so this is 1.43b. Okay, shows the symbols and formulas for respective voltage drop across an inductance. Voltage drop across the inductance is L into di by dt. Okay, and the voltage drop across the resistance is I into R. Okay, and the voltage drop across the capacitance is Q by C. It is given here L into di by dt, but using the relationship between I and Q. So what is the relationship between I and Q? I equal to dq by dt or Q equal to integral I dt. Okay, using the relationship between I equal to dq by dt, we have L into di by dt, you can write L into d square q by dt square. Similarly, IR equal to I into R into I is what? dq by dt, and this is q by c. Okay, now, okay, I will write here. So using Kirchhoff law, you can write here L into di by dt plus IR plus q by c equal to E of t. Okay, now using Kirchhoff law, we have this result from the relation using the relation I equal to dq by dt. From this equation, we will get this equation. Okay. Now, I think in this slide also, what we discussed in the previous slide, it is here. The voltage drop across the resistance E equal to IR, and similarly across the inductance L into di by dt, across the capacitance is Q by C. The relationship between I and Q, I equal to dq by dt or Q equal to integral I dt, and Kirchhoff law. The algebraic sum of voltage drops across the elements of closed circuits, okay, is equal to the applied voltage in the circuit. So using this, we have this result. So L into di by dt plus IR plus Q by C equal to E. So next, if you differentiate equation 1 with respect to t, sorry, if you differentiate equation 1 with respect to t, you will get L into d square I by dt square plus R into di by dt plus 1 by c into dq by dt equal to dE by dt. So if you differentiate equation 1 with respect to t, you have this equation. And from here to here, I just replace dq by dt equal to I. So everything in terms of I here. Yeah, because here I, here have q. I need everything in terms of I. That's why I will replace dq by dt equal to I. So this is equation number 2. Okay. So now, using the relation I equal to dq by dt in 1, so in 1, replace I equal to dq by dt, you will get equation number 3. You get equation number 3. Please check it. Okay. Now, this is the conclusion part. For an inductive circuit, that is a circuit containing resistance and inductance only. Thus, the current I is given by the equation L into di by dt plus IR equal to E. You got this one from equation 1, that is in the previous page. Similarly, for the suppose the circuit containing resistance and capacitance only. Okay, then the current I is given by the following equation. So this you got from equation 2. Equation 2 is this equation. Okay, this is equation number 2. This is equation 3. So the circuit containing resistance and capacitance, okay, R into di by dt plus I by C equal to di by dt. Similarly, a circuit containing a capacitance and resistance. So you got from equation 3, R into dq by dt plus q by c equal to E. So you should remember these 3 results. Now we'll go to the problems. The first problem is write a differential equation of a circuit containing a resistance R and an inductance L in series with an inverse voltage E, hence solve the same. So I need a differential equation. Okay, so anyone of them tell? So I don't know who is from ECE, EEE and I. Okay. So at least any one of them try. What about Shiva Shravanath? Shiva Shravanath. Okay, anybody?
Sir, L into di by dt plus, plus q by c equal to E.
L into di by dt correct சொல்லிட்ட.
Plus IR. Plus IR.
Plus IR, yes, correct. L into di by dt plus IR. Very good. Plus IR equal to E. Okay. Now, throw out a divide by L. So di by dt plus R by L into I equal to E by L. So this is a linear differential equation in I. So this is linear differential equation in I. Okay. So solution of this differential equation is solution of this differential equation is I into e power integral r by L into dt equal to integral e by L into e power r by L into t, okay, into dt plus c, okay, because this is q, right hand side, it's a constant, into e power integral integral r by L dt, okay, r by L dt into dt plus c. Okay, now this is I into e power. If you integrate this, you get what? RT by L. Okay, so e by L integral e power RT by L into dt plus c. Okay, now if you integrate, okay, now next you need to integrate e power RT by L. Okay, I'll write in the next page. So I into left hand side is what? I into e power RT by L. Okay. Right hand side is E by L is a constant. Okay. E power RT by L. I don't need the integration now. So integrate e power RT by L divided by R by L plus C. So LL gets cancelled. Okay, so throughout divide by e power RT by L, you will get I equal to E by R. LL gets cancelled. If I divide throughout by e power RT by L, e power RT by L gets cancelled, plus C divided by e power RT by L, or you can write e power minus RT by L. So this is the solution. This is the solution. Okay. So now I will take the name list. It is better. Then I can easily identify who is coming from triple E group. Okay, wow. Mechanical, mechatronics, computer science. I think this section there is no easy triple E students. Okay. So next option. Okay. So then second column. So the current I in an electrical circuit containing an inductance L, okay, containing an inductance L and the resistance R in series and acted on a periodic electromotive force E sin omega t. satisfies the equation L into di by dt plus Ri equal to E sin omega t. Find the value of current I at any time t if initially there is no current in the circuit. So in this problem, the differential equation is given. Okay, so you need to find the value of the current I at any time t. Okay, you should find the current I at any time t. So if you know how to do it, you can try. Okay, if you got the answer, you can tell. Okay, try. So the given equation is L into di by dt plus Ri equal to E sin omega t. So if you divide by L, so di by dt plus R by L into I equal to E by L into sin omega t. Okay, now again this is the linear differential equation in I. So the solution is I into e power integral R L dt equal to integral q is what? E by L into sin omega t into e power integral pdt. P is what? R by L into dt plus c. So now what is the left hand side? I into e power rt by L. So this is the left hand side. Right hand side is e by L into e by L is a constant. So this is what? E power rt by L into sin omega t into dt plus c. Okay, wow. So up to this step you can do it. Now I'm going to ask a small question on integration. What is the integration of e power ax into sin dx? I think you maybe studied this one in the 11th standard. Integration. Okay, wow. 11th standard integration. I think in the 11th standard. Or 12th, I don't know exactly. I'm okay. So just recall and then tell. So this is open to everyone. Actually, using by parts only you use here, but derivation is also there in your book, maybe. Okay, suppose if your teacher, I don't know whether, I think at least Andhra Pradesh students studied this one. So anybody? Manikandan?
Say no idea.
No idea.
So e
Aditya?
power a divided by a square plus b square.
Pragdish, சொல்லுப்பா. சொல்லு. E power?
E power ax divided by a square plus b square.
Very good.
Into a sin bx minus b cos b.
A sin bx minus b
cos
b. Where you studied this one?
Sir, in the 11th I guess.
11th படிச்சேன். 11th படிச்ச மாதிரி தான் ஞாபகம் எனக்கு. ஓகேவா? That's why okay. ஸோ சில ஸ்கூலில் வந்துட்டு டைரெக்டாக 10th முடிச்சுன்னா 12th போயிடுவாங்க. ஓகேவா? அந்த மாதிரி ஸ்டூடெண்ட்ஸ்க்கு சான்சஸ் இல்லை. ஓகேவா? ஸோ அதனால் வந்துட்டு 11th படித்த ஸ்டூடெண்ட்ஸு கண்டிப்பாக ஞாபகம் இருக்கணும். Similarly, please search integral e power ax into cos bx dx also. Otherwise, you can check in the net also. Suppose if you don't have 11th book, check in the internet what is the result for e power ax into cos bx. These types of result you will use, okay, in the third semester. Okay, third semester, first unit is Laplace transform. So Laplace transform. So everything is Laplace transform integration. So you need these types of results. So please remember, okay, these results. Okay. Now I am going to use this result here. Here a equal to r by L, b equal to omega. B equal to omega. Okay. Now left hand side I into e power rt by L equal to e by L. Okay. So e power a is r by L into t divided by a square plus b square. Okay, r square divided by L square plus omega square into a is r by L. A is r by L. It is sine b is omega t minus b omega cos b is omega t. Okay, plus c. Now remaining part is a simplifications. Remaining part is simplification. E by L. Okay, e power rt by L. Take L square is LCM. R square plus omega square into L square. Okay, so R into sine omega t minus L omega. Take L is LCM. L omega cos omega t by L plus C. Okay, I think here I missed L square. Okay, after taking so here have L, here have L, so L square gets cancelled. So I write in the next page, left hand side is what? I into e power rt by L, so is equal to okay, e by L e power rt by L divided by r square plus L square omega square. Okay, remaining is what? Remaining is r into sin omega t minus omega L into cos omega t. Okay, plus C. I think I write everything. I think I don't write here L because L square gets cancelled. So should write only E. Okay, now throughout divide by e power rt by L because I need I in terms of t. So E by r square plus L square omega square, okay, into r sin omega t minus omega L cos omega t plus C divided by e power rt by L or e power minus rt by L. So this is the required answer. I, the current I in terms of t. So now what is the initial condition is given in the question. If initially there is no current, that means that t equal to 0, I equal to 0. So when t equal to 0, I equal to 0. So using this condition, we have 0 equal to E by R square plus L square omega square. So this is 0, this is 1, so minus omega L, 0 minus omega L plus C. So this implies C equal to L omega E divided by R square plus L square omega square. This is C. Now substitute the value of C in equation 1. So not this equation, this equation. Substitute the value of C here. So 1 implies I equal to okay. So I will write again, please check it. E by R square plus L square omega square into R sin omega t minus omega L cos omega t. Okay, plus C into e power minus RT by L. C is just now we got it, L omega E by R square plus L square omega square into e power minus RT by L. Okay, so now I am going to simplify further little bit. Okay, so for this I am going to take commonly I am going to take E by root of R square plus L square omega square. So you may ask to me, so even you can take R square L square omega square, why I am taking root. Maybe for the question the answer maybe you will get it within 2 steps. Okay, so R by root of R square plus L square omega square into sin omega t minus L omega by root of R square plus L square omega square into cos omega t. Okay, plus okay, this is common. Okay, for everything. The numerator is L omega. I think I take E commonly divided by root of R square plus L square omega square into e power minus RT divided by L. So I took this is common. Now the right angle triangle I'll take. So this is 90 degree, this is phi. This is the side is L omega, this is R. This is root of R square plus L square omega square. So now what is R divided by root of R square plus L square omega square? Can anyone tell? E by root of r square plus L square omega square. What is r divided by root of r square plus L square omega square from the right angle triangle?
Cos phi.
Yeah, cos phi, Subramanian. Okay. Cos phi into sin omega t. Okay. And then L omega divided by root of r square plus L square omega square is sin phi. Okay. Minus sin phi into cos omega t. Okay. And then remaining you have what? Plus again L phi, L omega. So L omega divided by root of r square plus L omega square is plus sin phi into e power minus rt divided by L. Okay, so this term is with the previous equation. Okay, don't confuse with. That's why I'll write one by one here like this. Now, this is sin A cos B minus cos A sin B. So you can write sin of A minus B, the first two terms. I will write in the next page I equal to E divided by root of r square plus L square omega square into sine of A minus B. A is omega t minus phi. Omega t minus phi plus sine phi into e power minus rt e power minus rt divided by L. I think this is enough. So this is a little bit a simplified form. So that's why I will write up to this step. So look at this circuit and any one of them tell what is the differential equation. So I am expecting one problem like this in the CA. Okay, just they will give the circuit only. So they don't give the equation. So you should be very familiar with these types of problem. Okay, so you should practice at least one or two problems like this. So who is ready to tell the mathematical equation?
2 into di by dt.
First, what is your name?
Sir, Lakshminarayan, sir.
Lakshminarayan. Okay, good. Okay, first general sollu. Okay, L into
di by dt.
Okay, I will write here. Okay, L into di by dt
Plus IR.
plus IR. Okay.
Yes, sir. Plus Q by C equal to E.
Okay, Q by C equal to E. Okay. Okay. But here, what is given? Okay, I think you are right. You are right. But it is better to take everything in terms of Q. Okay, so I think you know the relationship between I and Q.
D
I equal
squared Q by dt squared.
Okay, Dikshidava.
Yes.
Okay, yeah. So L into d square Q by dt square plus I is what? dq by dt. So R into dq by dt plus Q by C equal to D. Okay. So it is correct, Lakshminarayan. This is correct. but
Yes,
it
sir.
is better to write like this. Okay, so okay, good. Okay, thank you, Dishita. And then uh, dq by dt of 0 equal to 0 and q of 0 equal to 0.1. That is also given the question. So first you should write, here it is better to write the mathematical equation of the circuit. Okay, you should write the mathematical equation of the circuit. Now dot dot so L into d square q by dt square plus r into dq by dt plus q by c equal to v. Okay. So now substitute L equal to 2. 2 into r power, right? Jagannadhana. Jagannathan C. L into d square q by dt square plus r. R is 4 into dq by dt plus q by c. C is 1. Okay, so just write q equal to uh, what is v? V is given sin theta. Okay, sin theta. Now you can write this is d square by dt square is d square. So 2d square plus 4d plus 1 into q equal to sin t. So this is you can write like this, where d square equal to d square by dt square. Okay, now write the auxiliary equation. So auxiliary equation is 2m square plus 4m plus 1 equal to 0. Okay, so I don't divide by 2. The reason is if I divide by 2, here we have 1 by 2. Okay, that's why I just keep as it is. Okay, so m equal to, what is the solution for the two roots? Minus d plus or minus root of b square. B square is 16 minus 4ac is 8 by 2a. 2a is 4. Okay, so this is equal to minus 4 plus or minus root 8. Root 8 divided by 4. So minus 4 plus or minus root 8 is 4 root 2 or 2 root 2 divided by 4. This one you can write minus 1 plus or minus 1 by root 2 divide by 4. Okay, so now take LCM. Minus root 2 plus 1 divided by root 2 and comma, and then one more root is minus root 2 plus 1, sorry, minus 1 divided by root 2. Okay, or you can write this is 1 minus root 2 by root 2 and minus 1 minus root 2 by root 2. So this is alpha. Take this is alpha, this is beta. So this is alpha, this is beta. So the roots are real and distinct. The complementary function is CF is C1 into e power alpha t plus C2 into e power beta t. Okay, now particular integral. So 1 by 2d square plus 4d plus 1. Okay, right hand side function is sin t. So now this is type 2. So replace d square by minus 1 square. So 1 divided by 2 into minus 1 square plus 4d plus 1 into sin t. So which is equal to 1 by 4d minus 2 plus 1. So minus 1 into 4d plus 1 divided by 4d plus 1. Okay, into sin t. Okay, so this is equal to, on the numerator you have 4d plus 1, the denominator you have 16d square minus 1 into sin t. So again replace d square by minus 1, so minus 16 minus 1, so minus 4d plus 1, 4d plus 1 divided by minus 17, right hand side is sin t, sin t, which is equal to minus 1 by 17 into, if you differentiate t, you get 4 cos t plus sin t. That's sin t. This is your pi. So now your solution, you are solving for q of t. Okay, therefore q of t equal to pi. Cf is what? C1 into e power alpha t plus C2 into e power beta t, and pi is minus 1 by 17 into 4 cos t plus sin t. Okay, so now, so up to this is nearly 80% of the problem is over. So q, the charge in terms of t, so we got it, and here it is given q of 0 equal to 0 0.1 and dq by dt of 0 equal to I here it is q, it is I equal to dq by dt. Okay, first I will write this condition.
Sir,
So yeah, please then.
sir, in the PI denominator
Lakshmi, break our voice.
4D plus 3 or 4D minus 1, sir.
Uh, here,
Sir, in the particular integral, denominator 4D plus 3 or 4D minus 1, sir. Yes, sir.
actually, yeah, here it is 4d. Okay, okay, this is minus 2 plus 1 bane. So 4d minus 1.
Okay, sir.
Okay, so so maybe you done like this. If you done d square equal to minus 1 whole square, then d square equal to 1. So then 2 plus 3, so 4d plus 3. So already I told that this is wrong. Okay, okay, so anyway, uh, it's a reasonable question. And then, so what is the initial condition? Q of 0 equal to 0. So what is given here? Q of 0 equal to 0 0.1. So when t equal to 0, q equal to 0 0.1. Apply into, so 0 0.1 C1 into e power 01 plus C2 minus 1 by 17 into this is 1, so 4 by 17 into 4 plus 0. Okay, so C1 plus C2, okay, equal to 0 0.1 plus 4 by 17. So using calculator, please tell what is the right hand side value. Calculate.
0.3353.
So what is your name? Newcomer.
Sir, Aditya.
Aditya. Where you went? Last 1 month. Okay. I think last semester you are very active, but not this semester. Silently you are watching. Okay. Okay. So C1 plus C2 equal to 0.3353. So this is equation 3. Okay. So now next condition. Okay. Next condition is dq by dt. Okay. dq by dt. For this I am going to differentiate equation 2 with respect to t. So differentiate equation 2 with respect to t. Okay. So dq by dt equal to, if you differentiate this, you'll get the C1 into alpha into e power alpha t. C1 into alpha into e power alpha t plus C2 into beta into e power beta t okay, and then sorry, and then if you differentiate this, minus 1 by 17 minus 1 by 17 into minus 4 sin t plus cos t. So please check it. Okay, now the condition is, given condition is dq by dt of 0 equal to 0. Okay, so this implies dq by dt equal to 0 when t equal to 0. So I'm going to apply this condition in this equation. So left hand side is 0 dq by dt. So C1 into alpha plus C2 into beta, and this is 0. Here it is 1. So minus sign. So minus 1 by 17. So C1 alpha plus C2 beta equal to 1 by 17. What is 1 by 17? The calculator, because there also I used it for, decimal. So that's why I need a
0.058.
0.058. Yes, correct. Thank you. I call this is equation 4. Equation 4. So now I leave it to you. Okay, I'll write again the previous equation. What is the previous equation? C1. Okay. What is the previous equation? C1 plus C2. Okay. C1 plus C2 equal to 0.3353. So this is equation 3. So I leave it to you. So you should solve these two equations and find the value of C1 and the C2. Alpha and beta value you know. Okay, alpha beta value you know here. This is alpha 1 minus root 2 divided by root 2, and beta is minus 1 minus root 2 by 2. So please post in the group. So once you got the values of C1 and C2, okay, and substitute the values of C1 and C2, equation number 2. In equation number 2, you should substitute C1 and C2. So it is just a calculation. So I don't want to spend time here. So I will go to the next one. Okay. So now, yeah, please tell.
So C1, C2 answer.
இல்லை ஆன்சரே C1 C2 நானே போடல, அதனால தான் உங்களுக்கு கண்டுபிடிச்சு சொல்லிருக்கேன்.
Okay, so yes, actually I got it. That's why I want to
Okay,
check.
please tell. Okay, we'll check it.
Minus 0.067
இது
C1.
கொஞ்சம் பொறுமையா கார்த்திகேயன். C1 equal to minus
0.067.
0.607
067.
067. Okay, C2
C2 0.191.
191.
Yes.
Okay, so please, remaining students, please check it whether this is correct. It will satisfy the third equation. Check பண்ணலாமா டைரக்டாவே? We add
C1 as
1 point.
0.346.
Please wait. First, I will check this one. 0.067. It does not satisfy third equation, Karthikeyan. So,
Okay, sir. I'll check it.
okay, no problem. So that's why you should do a little bit carefully.
Sir, I got C1 0.4635.
C1 Subramanian Solba. C1
4635.
0.4635.
C2 minus 0.128.
128. Okay. Just I will check the second equation.
Yes, sir.
I think it is working correctly. Oh yeah.
Yes.
0.4635 minus 0.128. So I think 0.3355. Okay, okay. It is very near to equation 3. And only thing we should check the first equation also, because alpha and beta value is shown. Okay, so I think this is correct. The remaining students should check again. Okay, once again, and if there is any correction, please post in the group. So once you got the values of C1, C2, as I already told that, substitute in the equation 2. Okay. Now I'll go to next problem. Too much time. Still we have time. Okay. In an LCR circuit, I think 1 to 2 lunch class up உங்களுக்கு.
Class, sir. 1 to
2 class. So maximum I will take 12:15. So 45 minutes for break, lunch. Okay. So next problem. So I will stop with this problem. This is the last problem. Okay. In an LRC circuit, the impulse voltage is 400 cos 250 t volts. Find the current in the circuit when t equal to 0.001 second, if L equal to 1 Henry, R equal to 400 ohms, and C equal to 0.16 into 10 to the power of minus 4 Faraday. Okay, and the initial charge and currents are 0. Okay, now my first question is whether you saw this question anywhere. எங்கேயாவது பார்த்துருக்கீங்க இந்த கொஸ்டினை இதுக்கு முன்னாடி? Okay, so think and tell. I don't want to waste my time. Now, the second question is, what is the differential equation for this problem?
L d square q by dt square plus
Aditya, சொல்லுங்க. L
d square q by dt square.
Okay.
Plus r dq by dt.
Okay. Good.
Plus q by c.
Okay.
Is equal to E of t.
Very good. So it is given. It is given here in LRC circuit. The impulse voltage is given. Okay. Okay, and then R. Okay, R is given. So and L is also given. RL and C is given. Okay, and the initial charge and the current are given. Okay, initial charge and current is given. So you may ask, why don't we write in terms of I? Okay, So I think it is better way to write in terms of q. So you can get, once you got q, okay, you can get I by just differentiating q. You can easily get I. Suppose if you get I, okay, suppose if you get to get q, so you need to integrate it. Okay, so that's why it is better to write like this. First find q. Okay, even if they ask, current I, first you find q, and then if you differentiate, you can get I. Now, what is L? Okay, L is 1. Okay, so d square q by dt square plus 400, R is 400, dq by dt plus q by c. What is a c? 0.16 into 10 to the power of minus 4. Okay, is equal to E of t. What is E of t? 400 into cos 250t. Okay, so now on the next page, I'll write d square q by dt square plus 400 dq by dt plus so this is actually 10,000 divided by 0.16. So using calculator, tell what is the value. 10,000 divided by 0.16.
62,500.
Yes, 62,500. Okay, which is into QR. Okay, into Q equal to 400 into cos 250t. Okay, now just rewrite this equation. D square plus 400d plus 62,500 into Q equal to 400 cos 250t. Okay, this is equation 1. So now the auxiliary equation is, so if anybody got the answer, you can tell the final answer. Okay, the auxiliary equation is m square plus 400m plus 62,500 equal to 0. So this is the auxiliary equation. Now m equal to minus b, so minus 400 plus or minus root of b square is 400 square, that is 1,60,000. Okay, minus minus 2ab, 2 into b square minus 4ac. 4ac is 1, c is 62,500. I think 2,50,000 up. 3,50,000. Okay, divided by 2a. Yeah, okay, thank you. So now this is equal to minus 400 plus or minus, so this is root of minus 90,000 divided by 2, okay, which is equal to minus 400 plus or minus I, because our root of minus 1 is I, into 300 divided by 2. If you divide by 2, you get minus 200 plus or minus I 150. Alpha is minus 200, beta is 150. Now the complementary function is equal to e power minus 200t into a cos 150t. So usually you'll use C1, C2, C1, C1, C2, okay. C1, C2 into sine 150t. So this is the complementary function. Particular integral. What is the particular integral? Anybody got the particular integral?
1 by 250 into sine 250t.
1 by 250 into sine 250t. Yes, correct, Dikshita. So now pi is d square plus 400d plus 62,500. This is actually okay. I need to find the p. What is the right hand side? 400 into cos 250. Okay. Now here I should replace d square by minus a square minus 250 square. Okay. So 400 into what I explained. Okay, 1 by and d square is minus 62,500 plus 400d plus 62,500 into cos 250. So minus plus gets cancelled. So here have 400, here have 400 gets cancelled. So 1 by d into cos 250. So you get, if you integrate this, you get sine 250 divided by sine 250t t, then also t, so 250. Okay. Now this is your pi. Now,
Sir,
please tell.
sir, his final answer is 0.3 ampere.
0.3225 ampere. Yes, correct, Aditya. Very good. Okay. So now in the last step pi. Yeah. Okay. So we are solving for q. Okay. So q or q of t equal to cf e power minus 200 t into c1 into cos 150t plus c2 into sine 150t, okay, plus 1 by 250 into sine 250t. So this is your solution. I think this is equation number 2. Okay, and what is given the question? Initial condition, initial charge is 0 and initial current is 0. So initial charge is 0 means, okay, given, okay, when t equal to 0, q equal to 0. So initial charge is 0. So now you should use this condition in equation 2, that 0 equal to e power 0 1. Okay, so now this is c1 plus this is 0 plus c. So this implies c1 equal to 0. Now substitute c1 equal to 0 here, you will get q equal to e power minus 200 t, okay, into c2. I will write c2 here, c2 into e power minus 200 t into sine 150 150t plus 1 by 250 into sine 250 into t. Okay. Now, so we need to differentiate because what is given here, initial condition is given here. The question. Please check the initial condition. The initial current is also 0. Initial current is 0. That is I equal to dq by dt. Okay, I equal to dq by dt. So which is equal to C2 into, okay, if you keep e power minus 200t as it is, okay, and if you differentiate sine 150 t, you'll get cos 150t, which is t into 150 plus you should keep C2 into sine 150t. Okay, you should differentiate e power minus 200t. You'll get the e power minus 200t into minus 200 plus 1 by 250 into cos 250 t into 250. So 250 gets cancelled. I call this is equation number 3. So I'm not going to simplify this. The reason is, what is the next initial condition we need to use? Anybody? What is the next initial condition we need to use? Initially the current is 0.
Equals to 0 and dq by dt equals to 0.
Yeah, when t equal to 0 is correct. D equal to dq by dt equal to 0. Current I equal to 0. Okay, I equal to 0. So now substitute t equal to when t equal to 0, I equal to 0 in equation 3. Okay, so I'll get 0, which is okay. Here we have 150 into C2. 150 into C2. Okay, and this is 0 because sine term is here. Okay, and here 250 gets cancelled. This is cos 0 1. Okay, plus 1. So this implies C2 equal to minus 1 by 150. Okay, we got the C1 and the C2. Substitute the value of C2 in this equation. Okay, இதை வந்துட்டு 3 வச்சுக்கலாம். 3. This is 4. This is 4. Okay, and 3 implies, equation 3 implies. Okay, now substitute the value of C2 here. Okay, substitute the value of C, and we need a Q or E question. Find the current I. Okay, or current I. So it is better to directly find I. Okay, there is no need to find I because here you can substitute in this equation itself. You can substitute C2. Okay, directly you can get the current I. So once you substitute here, next you need to differentiate again. So differentiation means again you need to get the same thing. So instead of 3, I will choose 4. Okay, 4. So I equal to, I need current. So I equal to dq by dt equal to, okay, C2 is minus 150. Sorry, C2 is minus 1 by 150. Okay, and then Here you have 150. So I will write 150 into e power minus 200t into cos 150t. 200t into cos 150t. Next term is minus 200, but the C2 is minus 1 by 150, so minus into minus plus. So 200 divided by 150 into e power minus 200t. So please check it into sine 150t. 150t. And the last term is 250, 250 gets cancelled, cos 250. 250t. So now I equal to, first I will write this term, 4 by 3 e power minus 200t into sine 150t minus, this is 1, e power minus 200t into cos 150t plus cos 250t. I call this is equation 5. So now we need to find one more thing. So what we need to find? Anyone tell?
Current at t is equals to 0.002.
Yeah, current at t equal to 0.001. That is asked in the question. Okay, correct. So 4 by 3 into e power minus 200 into, sorry, directly multiply. Okay, so 200 by 1000, that is 0.02 into 150 divided by 1000 is 0.15 minus e power minus 0.2 cos 0.15 and plus cos 0.25. So I think already Aditya told the answer. So please verify. I am also getting 0.3225 ampere. And I asked the first question for this problem. So whether you seen this problem already, for this question I don't get the answer. So please check your assignment number 2. That is the previous year CA question paper. I think I saw that similar type of question. So that's why I told that. So please check it. And if it is the same question, okay, there is no, I think if even it is the same question, you can practice one more time. If it is not the same question, a little bit different, then you can try that question. Okay, thank you. We'll meet again Monday. Monday, maybe I will take first hour. I will inform you through WhatsApp. Okay, thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you. Thank you, everyone.
Thank you, sir.
Thank you.